Okay, so this is part 2 of our videos on the dot product, and we're going to be focusing in on what we're going to call the law of cosines. Alright, so this is like a vector version of the law of cosines that you get in Euclidean geometry. So let's make a statement of what this says. I have to have two vectors, A and B, and I'm going to put them in R3, but they really can be in R anything. This can be scaled up to any finite number. And we're going to say here that the law says that the dot product is equal to the magnitude of A times the magnitude of B times cosine of theta, where if I have a vector A and I have a vector B, theta is the angle in between them. So what we're doing here is we're making a relationship between the dot product and the angle between the vectors. And that should be helpful to do some actual geometric analysis. Okay, so proving this takes a little bit of work. We're going to start off with the drawing that we just had a moment ago. But just for simplicity's sake, I'm going to call this one vector B. I'm going to call this one vector A. And we're going to play this out as though there's a triangle here. So we're going to call this point B, point O, point A. This is our angle theta, which means that this vector, the one going this way from B to A, is going to be the vector A minus B. So you might need to look back at your notes on vector subtraction, but that should be fairly straightforward once you take a look at that. Alright, so if you use the old school geometry here, right? So the distance from A to B squared should equal the distance from O to A squared plus the distance from O to B squared minus 2 times the distance from O to A times the distance from O to B times the cosine of theta. So this is just a restatement of the law of cosines that you get in Euclidean geometry. So if you need to go review that, I'm sure there's plenty of video footage for that online. Make sure that you've seen that somewhere. Okay, so we're going to rewrite. Okay, so we're going to rewrite this in vector form. The distance from A to B is the same as the magnitude of A minus B squared. The distance from O to A is the same as the magnitude of A squared, and this is going to be plus the magnitude of B squared, because OB is the magnitude of B, minus 2 times the magnitude of A times the magnitude of B times cosine theta. Okay, so this is where we're going to get a little clever. We're going to examine this, the left-hand side here. Okay, so if I examine the left-hand side, I'm going to get that the magnitude of A, or the magnitude of A minus B squared should be, well, A minus B dot A minus B. So this is from one of the properties that we got in the last set of notes, that the magnitude squared is the same as the dot product of something with itself. Okay, so this literally, because distribution holds, becomes foiling, right? So this is A dot A minus A dot B dot dot minus B dot A plus B dot B. So that's just binomial multiplication, which holds because we have a distributed property. So again, a vector times itself under the dot product is the same as the magnitude squared. I now have two of these because the commutative property holds under the dot product, and then vector times itself is the magnitude squared. Okay, so what does that mean? If I go back here, I can now make this the left side of the equation. So I now have magnitude of A squared minus 2A dot B plus the magnitude of B squared is equal to the magnitude of A squared plus the magnitude of B squared minus 2 times the magnitude of A times the magnitude of B times cosine theta. Now here's the beauty. That's on the left, that's on the right. That's on the left, that's on the right. There's a negative 2 in both places, so I'm going to end up with A dot B is equal to magnitude of A times magnitude of B times cosine theta, which is precisely the law of cosines. Okay, so this gives us a way to go between the dot product and the angle measure. Woohoo! Alright, so we just proved, again, one more time, is that A dot B is equal to magnitude of A times magnitude of B times cosine theta. Probably the more useful corollary to this would be that if I rewrite this, I get that cosine of theta is magnitude of A dot magnitude of B, vector A dot vector B, divide by magnitude of A, magnitude of B. Okay, why is this relevant? Because ultimately, this is how I'm going to get the angle measure from the two vectors. I plug them in here, take the inverse cosine, and I will get a theta measure for the measure betweenst the two vectors, theta. Woohoo! Okay, so thank you, and we'll continue from there.